Year 10 Polynomial Exam Practice Question 12. Function of x is equal to x to the power of 3 plus x squared plus ax plus b, where a and b are constants. When function of x is divided by x minus 2, the remainder is negative 7. When function of x is divided by x plus 1, the remainder is 32. We need to find the value of a and the value of b. So to do that, we need to understand the remainder theorem. And that is, if I use the function, use this as my factor, which is x is 2, I am ending up with a remainder of negative 7. So that's the first thing I need to think about. So I'm just going to evaluate, and whenever I've got an x, I'm going to put in x of 2. So 2 to the power of 3, I've got a plus x squared, so 2 squared plus a times x of 2 plus b. And I know that is going to equal negative 7. So I can simplify this. I've got 2 to the power of 3 is 2 times 2 times 2, which is 8. 2 squared is 4 plus 2a plus b is equal to negative 7. I can simplify this part with 8 plus 4 equals 12. So now I have 12 plus 2a plus b is equal to negative 7. I'm going to get all my constants onto one side, so I'm going to take away 12 on both sides. That gives me 2a plus b is equal to negative 7 take away 12, which gives me negative 19. Okay, the next thing I look at is my next one, where it says I've divided by x plus 1, and the remainder is 32. Again, I'm using my remainder theorem. So if x is negative 1, because that will mean that's 0, I'm left with a remainder of 32. So based on that, I'm going to substitute negative 1 into my equation. So I've got negative 1 to the power of 3, x is squared, so plus negative 1 squared plus ax plus a times negative 1 plus b of negative 1, and that is equal, not negative 1 plus b, and that's equal to 32. The next thing I need to do is simplify that. So negative 1 to the power of 3, well that's just negative 1. Plus negative 1 squared, negative and negative is a positive, so that's just plus 1. Plus a times negative 1, well that's just negative a. Plus b is equal to 32. Well, that negative 1 plus 1 cancels out. So I'm left with negative a plus b is equal to 32. Just to make it easier, I'm going to get my value of b onto one side, which means I'm just going to get rid of negative a and add a. If I add a to both sides, I am left with b is equal to 32 plus a. Okay, so now I've got this far. The next step that I need to think about is using both of these equations to solve. So I'm just going to make some space, and that just means I'm going to keep these two equations that I've come up with, and I'm going to use my understanding of simultaneous equations. So I'm going to substitute this as value of b. So that means I have 2a plus my b, and b is 32 plus a, is equal to negative 19. Now I can solve it. 2a plus 32 plus a. So 2a plus a is 3a. So I'm left with 3a plus 32 is equal to negative 19. The next step I'm going to do is take away 32 from both sides. If I take away 32 from both sides, I'm left with 3a. And here I've got negative 19 take 32. And that gives me negative 51. The next step that I need to do is get a by itself, and to do that I need to divide by 3. So I'm going, how many 3's are in 51 or negative 51? And that is going to be negative 17. Now I know a is negative 17, I can then work out what b is, because I just substitute it into this equation. So I've got 2a, which is negative 17, plus b is equal to negative 19. So 2 times negative 17 is negative 34. Plus b is equal to negative 19. So what do I need to add to get it to be negative 19? Well, that really just shows me, I look at the difference between 34 and 19, which is 15. So b must be 15, positive 15. So I've got my two values now. So that just means I'm able to rewrite this, and I'll take away the a. A is negative 17. B is 15. So now I'm going to do the last step and to double check by seeing that the x minus 3 is a factor. So I can rub out this part now. So that just means now, to find out if this is a factor, I'm going to use my understanding of factor theorem. And if I substitute 3, this should turn into equaling 0. So x is 3, so it's 3 to the power of 3. Plus x to the power of 2. So again, x is 3. Minus 17 times 3 plus 15. And that should equal 0. So 3 to the power of 3 is 27. 3 squared is 9, so I'm plussing 9. And then I'm taking away 3 lots of 17. So I'll do it on the side. 3 times 7 is 21. Carry it over. 1 times 3 is 3. 3 plus 2 is 5. So that's 51. So I'm taking away 51 and then I'm adding 15. So let's double check that. We need to go 27 plus 9, which equals 36. So now we've got 36, take away 51 plus 15. Well, 36 take away 51 is negative 15. So negative 15 plus 15 equals 0. So that shows me that x minus 3 is a factor. It also double checks my answer for A and B. So if you've missed it, My A value is negative 17, my B value is 15, and I've just proven that x minus 3 is a factor.